Hey there everyone, welcome to my talk called Animations from First Principles. My name is Rodrigo. You can find me on Twitter /x/whatever at MathsPP blog. I'm a developer at Textualize, so I work on the textual framework, and whenever I have the chance I write about Python at mathspp.com. So writing Python code and teaching Python, those are my two main activities. And in this talk, I want to write some Python code to teach you how to make animations from first principles. So the title of the talk is exactly what we're going to do. Now, the idea for the talk is that I show you because I'm saying from first principles, what I want to show you really is the concepts that let you create any animation from scratch. And so, although we will be using the Pygame package to draw on the screen, we don't want to use the methods that Pygame has to draw specific figures. So what I want to show you is how you take the atomic operation of drawing a single pixel or coloring a single pixel, how you take that operation to draw arbitrary figures, then animate the drawing of those figures, and then animate morphing between figures. So that's our starting point. And in order to do this, we're going to create a black RGB tuple, and then we're going to take a canvas. So let's create a canvas from our Pygame. So pygame.display.setMode. Let's create an 800 by 800 canvas. This really is the screen, but I'm calling it canvas for this talk because it makes more sense. Now we're going to fill the canvas with black. And now we're going to update the display. Flip. And now we create an infinite loop just so we can have time to look at the canvas. So here you have it. This is the black canvas. And now what we will do is we will draw a circle on the canvas. And again, we don't want to use a method that draws a circle. We want to draw it ourselves. And so in order to figure out how to draw a circle and in general how to draw any figure is you need to think of it as, or the way I like to do it is think of the way I would draw it with a pencil. I'm going to open a canvas here and I have a pencil, and the way I would draw it with a pencil is I would figure out some point, maybe here on the right, I would put the pencil down and then I would drag it over my canvas to draw a circle, right? This is how I would do it. And so we will mimic this behavior in Python, except that we cannot draw a continuous line. We can't do this. So what we will do is we will put the pencil down in a position and put a point there. And then we move the pen just a little bit and we put another point there. And then we move the pen and we put another point there. And then we move the pen and we move the pen and we move the pen. And by jotting down a bunch of points close together, we get the feeling that we drew a line. Although the only thing we did was draw single points. And the way in which we do this is we're going to define a function. We're going to define some function. Shouldn't have done this, but now I'll commit to it. So we're going to define a function that accepts a percentage of the progress of our drawing and returns the position of the pen at that point. So for example, if we've made 0% of our drawing, then the pencil should be right here. If we've made 50% of our drawing, then the pencil will be over here on the left, right? Because the actual drawing is to go like this. This was terrible, but the halfway mark is on the left. If we're at 25%, then the pencil should be right here. And if we're at 75%, the pencil should be right here. So what we'll do is we'll define a function that computes these positions. So let me call this function circle. So def circle. It's going to accept this percentage of progress, and it's going to return this position. Now, to compute the position, I need a little bit of maths, and in particular trigonometry, so the cosine, the sine, and pi. And so what I'll do here is I'll take the center of the screen, and I'll do a little bit of math, 2 times progress times pi. And then for the y coordinate, we're going to do a similar thing. 2 times progress times. All right. And now what I want to do is I want to make the drawing. And in order to draw something that looks like a continuous figure out of drawing specific pixels, what I need to do is I need to draw a bunch of points, because if they're close enough together, then it will look like a line. So we can do that. We're going to say that for point in range of, for example, 1000, this should be enough. The first thing I need to do is convert this iteration into a progress percentage. And I do that by taking the current iteration and dividing by the total number of iterations. And then what I can do is I can use the method setAt that accepts an XY position and sets the pixel at that position, in this case to white. I just need to set the color white, so that's going to be 255, 255, 255. And then the position is given by the function that we created. So now if I draw this and if I update the screen after drawing the circle, so let me take that and update the screen after drawing the circle, I should have a circle on the screen. It's not import math, it's from math. Silly me, sorry about that. So we can see there's a circle here. Now, the circle is very faint. It's very thin. So what I'll do is I'll create a small function that draws a thicker circle. So it's going to take an XY position and the color, and it's going to set the color on the canvas. Oh, that's wrong thing to call, so let's draw. So we're going to draw on the canvas. The position is given by XY, the color is given by the color, and the radius is to be thicker. Are these in the correct order? No, they're not. And so instead of using setAt, let's call drawPoint. Like this. And now if I rerun the code, I should have a thicker circle. Alright, so the only thing I did was I had to cheat a little bit here, and this pygame.draw.circle, just think of it as drawing a thicker point. So that's why I called it drawPoint. So I draw a bunch of points, and because I show it in the end, it looks like a complete circle. Now what I want to show you is how you can animate the progress. And to create an animation, the only thing you need to do is you need to create a bunch of static pictures and show them in quick succession. That's essentially it. And if you draw enough pictures and if the way in which you show them is quick enough, it's going to feel like it's animated. So in short, what we'll do is, as we go through the progress of drawing this circle, what we'll do is we'll draw a little bit and show the screen. Then we draw a bit more and then we show the screen. Then we draw a bit more and we show the screen. We draw a bit more and show the screen, etc. That's the way we will tackle this. So how can we do this? It's going to be similar to this loop, but now it's going to have two nested loops. So let's say that the FPS of our animation is going to be 60, and the duration of the animation is going to be 3 seconds, and so the total number of frames, the total number of pictures we need to draw is the number of seconds times the number of frames per second. That's right there in the name. And so this gives the number of frames we need to draw. And so for frame in range frames, we need to do something. Now, the something we need to do here is draw just a little bit of the circle. And so for each frame, we're going to draw 50 new points, for example. 50 new points. And now the only thing we need to do is figure out what's the progress we've made for each point. And the progress is given by a percentage of the drawing that was already drawn in the previous frames, that's frame over frames, and then a small advancement we make, we move the pen just a little bit, corresponding to the point we're at out of the 50. But this point out of the 50 is in relation to all of the frames that can be drawn, and then drawing the point is just the same thing, we just draw a point. And then what we want to do is we want to show progress after we've drawn each frame. So this draws the whole frame and this shows the frame. And so now we can get rid of this. If we run the code, we have our animated circle. Now it's going a bit faster than 60 frames per second, but then we can use Pygame to help us keep the FPS in check. And that's what this clock is doing. So tick FPS. So this just makes sure that we don't go faster than the desired frames per second. So there you have it. We're drawing a circle and we're animating the drawing. And I'll stress it again. One of the most important things here is that this function circle isn't special. This is just a function that accepts a progress percentage between 0 and 1 and returns the position of the pencil. So we can create any other figure so long as we create the appropriate function. And in mathematics, this is a parameterization of the circle. And so now what I'll do is I'll create a parameterization of the figure 8. And you're not supposed to, I don't know, come up with this formula by yourself or something. It's just you can look it up online. This part is fine. You can look up the parameterizations of the figures you want, or you can just play around with numbers and see what happens. And I look this up, and this formula is going to create a figure 8. So in here, in my drawing loop, instead of drawing a circle, I'm going to draw a figure 8. And so if I run the code, oops, I did something wrong. Sorry, I must have gotten the formula wrong. 8 return, sorry, this is not times, yeah, silly me, this is plus. Sorry about that. So then I have an animated figure 8. And the only thing I did was change the parameterization, right? Because the concept is the same. For each frame, we're going to draw a bunch of points, and we just need to move along the figure. So now what I want to show is, how can you morph two figures together? How can you do this? So the idea, or the thing you need to focus on, changed a little bit. Before, for each frame, we wanted to draw just a portion of the figure. Now, on each frame, we want to draw a whole figure, but we want to move from a circle to a figure 8. We want to morph the two together. And so at each frame, when you freeze the frame, what you need to figure out is how much morphing has already happened. If the morphing can go from 0% to 100%, how much percentage of the morphing has already occurred? And then you use that percentage to go from the circle to the figure 8. So how do you do that? Essentially, you put the two parameterizations together. You just need to find a way to combine the two together. And in maths terms, what I'm about to do is I'm going to do some linear interpolation. So this morphing is a number from 0 to 1 that defines how much morphing already happened, and this progress, again, it just tells you the position of the pen. So the first thing you need to do is you need to compute the position of the pen for the two figures separately. You compute the the positions for the two figures separately, and then you use a little bit of maths, again, linear interpolation, to determine how much from one figure to the other you've already gone. So how much morphing already happened. And this is the formula for linear interpolation. You can look it up later. And it's just morphing the two together. And so what I need to change in my loop is, for each frame, now I want to draw the whole figure. So instead of drawing just 50 points, what I'll do is I'll draw maybe 1000 points. And so the progress is again determined by the point over the 1000. And when I'm drawing the point, I don't want to draw the figure 8. What I want to do is morph the circle into the 8 with a given progress and with some given morphing factor. And this morphing factor is set by the number of frames that already elapsed. So now the number of frames determines how much morphing already happened. And in the end, we update the display. And the only thing that we need to do is to clear the canvas at each point. So for each frame, we need to remove the previous drawing and then draw everything from scratch. So something like this. Let's see. So this right here morphed two figures together. And again, there's nothing special about the circle, nor about the 8. Only thing we did was we parameterized both the circle and the 8, and then we used a little bit of linear interpolation to morph the two. So this is what I had to show in this short talk. I hope this was interesting, and if you want to take a look at a written version of the talk, and obviously the code, and some further things you can do, for example, animate with color and have gradients of colors along the figures, you can scan this QR code, which will take you to a written version of the talk. And you can also see my email over here at the bottom. Feel free to email me if you have questions, suggestions, if you have feedback. I will be waiting for you to write to me. So thank you very much for your time, and I'll see you around. Bye.